coming to the next concept, the important concept, limit cycle oscillation. While looking into the FIR filter, uh, in this case, it is free of limit cycle oscillation when implemented on a finite word length digital system. So, limit cycle oscillation concept. In the finite arithmetic operations, some registers may overflow if the input signal level becomes large. So, for example, if I am doing my overflow concept, I am trying to explain the overflow concept. If I am adding two numbers, for example, in the decimal system, I am saying 5 plus 3, right? So my locations, I am in need of storing my data 5 and 3. I am having one bit, for example, right? So one bit is used to store my first input 5, and second bit is used to store my data 3. And I am having my register to store my output, summation output. In that case, 5 plus 3 is 8. So my result can easily accommodated in my register. But if my data is 5 plus 7, so in that case, my result is 2. The next MSB is 1. So in that case, my register can able to accommodate only the data 2. I will miss the data MSB 1. So in this case, instead of 12, I will have the answer as 2. Right? So this is called overflow. So if the data is exceeding the limit of the capacity of our register, then overflow will exceed. So in the case of finite arithmetic operations, some register may overflow if the signal level becomes large. These overflow represents a non-linear distortion leading to limit cycle oscillation. So this overflow concept is the main cause for the limit cycle oscillation. There are two types of limit cycle oscillations. One is the zero input limit cycle oscillation, and another one is overflow limit cycle oscillation. So zero in the sense, the arithmetic operation produces the oscillation. So oscillation, in the case of limit cycle oscillation, it will produce the oscillation in our output. That is, it will oscillate between the two different values. It is possible, right? So it will oscillate between the two different values. So when will it happen? So one is with the input limit cycle, 0. So here, when the input is 0, so in that condition, our output should be obviously 0. Instead of that, I will have some other answer. So that will result to the zero input limit cycle oscillation or some non-zero constant values. So such oscillations are called zero input limit cycle oscillation. And coming to the overflow limit cycle oscillation, here this occurs due to the overflow of the adder, is known as the overflow limit cycle oscillation. So here the important calculation while doing our limit cycle oscillation computation, deadband. So the limit cycle occurs as a result of quantization effect in multiplication. The amplitude of the output during a limit cycle is confined to a range of values. That is, it is oscillate between two different values, from minus 5 to plus 5, or from minus 10 to plus 10. So it is confined to a range of values called the deadband of the filter. So the deadband is calculated with this formula. This is the formula for calculating the deadband of the filter.